Fine, sir.
Olayemi, I want to hear your voice. Olayemi got it.
Sir?
What of hour?
Yeah.
Yes. We just started the class. Unmute yourself and let's first talk before we start the class proper. Sorry. Ikú àgbà ni. Àgbà ń jẹ́ náà nìyẹn. The biological will say age of puberty. Which you can see the voice. So how was the test given to you? How did you find it?
Oh, it's fine.
Good. Like my Oga always says, it is not yet over until it is over. And I will say, mathematics is not a subject that we leave just like that. It's all about continuous practice. It's all about continuous practice. As you have at least done the introductory part of the calculus, let me call it introductory part. You only need to get the first question, check any relevant question, work them. Anywhere you find difficult, then you let us know. So what I'm trying to say is that you need to work on your own, not until when Messiah gives you 10. You need to work on your own. So I want to take another part, which is circle geometry. Sincerely speaking, everything is easy now. Let me use that word. Everything is easy now. But as you remember in those days, you must cram the proof. But you say, prove that this is equal to this is equal to that. Now start to rack your brain. Maybe 3 minutes to the exam. You take your book and start cramming. But now, the most important thing is how to apply all those theorems. Firstly, we'll start like this by first identifying part of a circle. Sorry, my circle is not that perfect. Let's just assume that one. Let us assume it's a perfect circle. We should be able to identify. Also look at this line. Please, each point I made, and I made emphasis on it, make sure you take note. Very, very important. If a line is drawn like this in a circle, don't ever assume that it's a diameter because you are not true. If in the question it is stated that, okay, let me put it this way, line AB is a diameter, then you can take it as a diameter. But if it is not stated, don't assume it's a diameter. But the moment a line is drawn this way and they put this to indicate the center. Okay? Let me adjust it to this. I think it's come a bit here. Okay? They have indicated the center for us. That tells us that this line is diameter, nothing more. The line is a diameter. If I draw a line here from one part of the circumference to the other part, then we call it a chord. This is a chord. If I share this part, then we call it a segment. A chord divides a circle into two segments, minor segment, major segment. Like I said, a chord divides a circle into two segments, minor segment, major segment. Also, what we call
please
a
move
section,
the
radio.
black icon on yours. Can move it up. Okay, yeah, great, thank you.
This part here is a section. A section has to do with the angle, but a chord does not have difference with the angle. So there are several Big ratio. But it depends on what they want to ask you. And I'm going to give you examples of what I'm talking about. I'm going to give you an example. So, once you have this one in mind, Pythagoras theorem and trigonometry ratio. When you say trigonometry ratio, we are talking about the show where you were taught what's it called? Your SOCA SWA. Your SOCA SWA. This is what we call trigonometry ratio. Sine, cosine, and tangent. All those ones may be used to solve questions on this fourth theorem. Okay, let me call it theorem number 1. Can I clean it up?
Yes, sir.
Okay. Let's look at the first example here. If chord is 4 centimeters from the center of a circle, if the radius of the circle is 5 centimeters, find the length of the chord. The chord is 4 centimeters from the center of the circle. If the radius of the circle is 5 centimeters, find the length of the chord. In this aspect of mathematics, you have to be very careful. You need a rough sketch of the question. You draw the diagram to represent the question. At times, when you draw the diagram and the diagram is accurate, maybe along the line, there's a mistake, there's a mistake in the calculation. The examiner will, pardon you and give you some marks on that diagram. Please take it, very, very important. Okay, let me assume that one. This is my section. This is the center. It's an assumption. Your compass will indicate the center. And then you call it 4 centimeters. Okay? This is 4 centimeters. And the radius is 5 centimeters. Radius. I want to look at it. A chord is 4 centimeters from, we are not given the length of the chord. Bear that one in mind. So if the radius is 5 centimeters, find the length of the chord. Don't forget that these two sides must be equal. It depends on the way you want to label it. I can say this is X. This also must be X because the two of them must be the same according to what the theorem says. So this is at angle 90 degrees. In that case, we can say using Pythagoras theorem, Pythagoras rule, you don't need to quote the rule again. You've already stated it here. You don't need to say a square equals to b square plus c square. Let area is g where it is. Just write using Pythagoras rule. Once you write that, there must be a mark for it. So the short hypotenuse, which is 5 squared, equals to 4 squared plus x squared. That's our unknown. So what we need is to bring the like terms together. Or let me first expand it. 25 equals to 15 plus x squared. Then we connect the like terms. We have 25 minus 15 equals to x squared. It means x squared equals to 9. X equals to 3. So if x is 3, remember, if you look at the question, there's no part of the question that says find the value of x. No. You can just say find the length of the chord. And for us to find the length of the chord, this is the length of the chord from this point to this. What we did there is just only half of length of the chord. So the length of the chord is equal to 2 multiplied by 3. This is 6 centimeters. This is where your final mark will be. If you get up to this point and you stop, there's no way you get the full mark. And the funny thing is this: if it was an objective question, definitely this answer will be the obligate. If we read the first option, this is option A, to take this place, we have to find the length of the chord, and the length of the chord is double of this value of x. Do we have a question on that? Unmute yourself and talk to me, please.
No, sir. No, sir.
Okay, good. Good. Awad, Ademola, I want to hear from you. Okay, what of Awad? Sorry, I'm calling the name I'm still on the screen. Just pardon me if I don't pronounce the name very well.
It's Awad. Awad. Awad, are you there?
So let me be.
Yes, I'm here.
I know he's calling you. You didn't answer. Please answer it. Okay.
Please, whenever I call your name, try to answer me because I believe in that word. The moment I call your name and you don't respond, that means you just put your system on and maybe you have gone to, take care of your stomach, which I believe some people have done before now. So you can get this one down. Let me give you just 2 minutes to write it down. 2 minutes. 2 minutes.
Can I make it big? 2 minutes. 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 2 Try make it big.
A big.
Okay. You
I
can't.
can't hear you
Okay.
properly.
No, can you make it big? Maybe you zoom in your camera. Zoom out. I think zoom out your camera. Yes. So that it will be bolder than this. That's what he's trying to say.
Please, let me tell them, I'm not using iPhone.
You are using a Z bone.
I'm using Infinite Pro Max. Infinite Pro Max. That's what I'm using.
I hope it's better now.
I hope you can see it clearly now.
Yeah.
That's why I decided to use one.
What about others? Can you see it?
Yes.
All right.
You have less than 1 more minute. Less than 1 minute. Write it down. Yes. I'm ready. You are ready. Yes, another example. Let me assume my center. So the length of a curve is 16 centimeters. Okay, I'll take it the other way. This is 16 centimeters. Don't forget, you draw this line. Sorry. It means this is 8 centimeters. This is also 8 centimeters. If the cord is 6 centimeters from the center, this is 6 centimeters. You have to find the radius. Find the radius. And according to the diagram here, radius is our hypotenuse. So it means r squared equals to 8 square plus 6 square. And that will be what? 64 plus 36. And that is 100. So R equals to 10. So radius is equal to 10 centimeters. You can see how cheap the question is. When you first look at the question, you think it looks somehow, but the interpretation is very short, very simple and direct. Just make sure you interpret the thing very well. Interpretation matters a lot, most especially when it comes to mathematics. Interpretation matters a lot, please. Very, very important. So just sit down, just sit down. Like I told you, we have several ways by which they can give us questions. So I'll give you the last example on this before we move to another theorem. Quickly write it down. But I know many of you always find careful difficult to draw. So it's not that to draw the circle. I thought I did that circle, now we do a circle because we perfect circle. So we are writing the exam, we have to start with it's not a perfect circle. Or you come back. So the last example I want to give you on this house. Is called the 12 2000 from S and angle theta are the center of the circle. If the radius of the circle is 10 centimeters, calculate the value of theta. Because of length, let me read it. It says to take time, some of us. Because of length, 12 centimeters, compared and angle theta at the center of the circle. If the radius of the circle, the dimension if the radius of the circle is 10 centimeters, calculate the value of theta. Let me draw a circle. Here, that's the because we are doing this center. Here, that's the theta. If you look down, how to make it bigger? So that's the line, so it's more clear. an angle of theta at the center, and then the length is 12 centimeters, radius 10 centimeters. So we have not done this aspect, but I will use two methods to solve it. Two methods to solve it. I will use two methods to solve it. So, according to the theorem, the greater than this, it was not defined to same thing. Right angle triangle, meaning that this angle 2 is half of theta. This also half of theta. The line of right angle, like I said earlier, that the kind of the total triangle we have inside is an isosceles triangle, and let's say it's an isosceles triangle. That means this side and this are equal. The moment they are equal, and the very line perpendicular to the base, that line must divide this angle into 2 parts. Very important. That is very important. Are we together? So, let us see what right angle triangle are. This is what we are. I want to try this. So we have this, half of this angle. Given an angle opposite and different. That's a relation of trigonometry ratio. These are two factors. So that opposite and different, that is so. We use time theta over 2 equals to 3 over 10. So this time we are going to help you here. But I don't have any calculator or subconcept here. Sin theta over 2 equals to 0.8. So theta over 2 equals to sin inverse of 0.8. Is that right?
Yes, sir. Yes, sir.
Inverse of 0.6.
Huh?
Sin inverse of 0.6. Or is any one of you there who wants to help me out?
Yes, sir. 36.86. 36.87.
36.87 degrees. Good. So it means our theta, others please try to confirm. You know, it's whatever the first for me that I'm right. Raise up, everyone multiply that one by 2.
Side over inequality by negative number.
3.7. Okay. So that's the answer at the center is 73.74. Now, I don't want to forget the case. Our length of chord is 2r by theta over 2. So we can use one of to find this out. Do the same thing as okay. But maybe we should try it and see. Let us have a table. That is our 12 because we should multiply by 10 by theta over 2. So 12 equals to 20 by theta over 2. Then sin half theta equals to 12 over 20. 2 getting at 0.6. So theta is also equal to 73.44. So if you can connect the formula, if it's a question like this is given to you, then you can apply that formula to solve it. But if you cannot connect the formula, just figure out. Mostly I do formula, how do you derive it? That's why I use this particular method so that it's not created kind of confusion. But if you can still remember it, you can still apply it. Do the same way Henry does that. Do you have any question on this? If you have question, unmute yourself and ask your question. Okay, you can drop it down. You drop it down. Okay. From Philip, and pick another theory. Yes, the next current is the output which and are of the circle substance and the center is twice which the substance on the remaining part of the circumference. The angle which an arc of a circle subtends at the center is twice which is subtends on the remaining part of the circle. I want to look at this video. An arc is this thing is running the same arc. The arc is an arc of the circle subtends at the center is twice which the arc subtends on the remaining part of the circle. Very, very important. Very, very important.
Sir, your screen is not clear.
It's blurry.
Yes, sir.
Okay. Is it okay?
Sir?
Please, come. Hold on. Please stop. Hold on. Adimola.
Sir, can you please repeat the question? I can't see it very well.
I will read it for you. I will read it. Someone said the screen is blurry. Adimola, is it blurry there?
Yes, Okay. Hold on. I will knock out and come in again.
Okay, sir.
Is it a bit better?
Yes, sir.
This is better.
The angle and arc of a circle subtend at the center is twice which is subtend on the remaining part of the circumference. That's what I was talking about. And because the camera will not capture the whole ball, that's why I try to fit in a switch in so that we have that to draw this. I'm really sorry for that. Now, this and I, let me call it activity. Let me call it activity. We assume this is the center of the circle. That assumption. Don't forget that one. Okay, you center of the circle. With an activity, subtend it angle at the center. We angle with an arc of the circle subtend at the center. At the center, this angle is subtend at the center. In twice, which is subtend on the remaining part of the circle. This is the proper angle of the circumference again. That angle of the atom. That's what it's going to be. It's not good at that. From this point, if I go like this point, if I go like this, sorry, okay. What I'm trying to do now, this angle here, let me do this 1.2. This, let me do 1.2. This angle will always go on the 2 times angle ACD. That's it. The angle with an arc from center to center twice one with the same angle compared to the part of circle. If I draw this one like this, one like this, the same angle which I either this one as point B. It means AOB doesn't get 2 times A. Are you getting me? So any angle is not on the circumference must be out of the angle is formed at the center. That's what Theorem is saying. So what we need to do here is that one. What is the Theorem talking about? How do we apply it? Like I said in the beginning of this topic, that in this thing, they will ask us to prove that angle with an arc of the circles of them like center is twice what we need to prove that time. But now, nobody is asking you to prove anymore. So, when let us assume that this angle is like 62 degrees, and we know this 62 degrees. We know this angle must be 1. This also must be 1. This also must be 1. Angle with and the center is what one is from or the remaining part of the circle. Do we ask question on theory?
Before they ask questions, sir, please, I want to quickly say something. Can I go ahead, sir? I said. Oh, sorry. Hello, sir. Yes, please. I said before they ask question, can I quickly ask some questions? I want to chip in something. Okay. Nam. Okay. Thank you so much, Mr. Additional, and may Allah bless you for this work you have done for us. And my dear students, I want to quickly say this. You notice that I sent something about 3 days ago on English. You know, there's no way you are preparing for your work, and there's no way you pass maths and you have issue with English. No university or polytechnic will give you admission. So that's the reason why, and I have invited an expert in that field to come and talk to you on some aspect of English tomorrow and on Thursday. I noticed that only few of you have joined the group. So if you have not joined, I want to advise you to join. It's just come and see what he has to give you, what he has in stock, and if it's something that is good, we can make an arrangement for that for you for GS3 and SS3. I'll be expecting you to join the group. I've shared the link again today. So tomorrow we're having the class tomorrow. I'll share the details again on the platform, and that is one. Two, tomorrow you are going to do your assessment tomorrow, because after today's class our next class is going to be on Wednesday, and that's going to be the last class for this free holiday class. So after that, so we are going to start our weekend booster on Saturday on the 10th of January. So if you have not registered, so you have the time, you have the opportunity, so that you'll be able to continue with what you have started. You can see you see that as the way we are doing it, we are doing that gradually, so that we want everybody to understand the concept very well before you get to your exam hall. So you know your exam is fast approaching and you don't have time, so you have to act fast. So you have not registered for the weekend boosters. So this is the time for you to go and register. I have the details are there on the community. I will also share the details today in our group. All right. So that is what I want to tell you. Thank you. If you have any question, you can reach out to me on my WhatsApp for further explanation on this. So thank you. So Mr. Addison, over to you. Can continue, sir.
Okay, before we continue, I say, is there anyone with questions before we continue? Okay, let me put it this way.
No, sir.
Based on the diagram we have on the board, what is all your observation? What do you observe? If you want to talk, just omit yourself and talk to. What do you observe?
So can you repeat your question?
I said, based on the diagram we have on the board, what do you observe? Okay, you observe nothing. Okay, no problem. Before I answer the first question, I think I looked at my screen and I saw it.
No, sir. You cannot see the lower part, just the upper part. The part of the Z equals to Y equals to. Yes, sir. Yes, sir. Yes, sir.
Degrees here. They say what's the value of X, what's the value of Y. You know, say X equals to 53 degrees. You are right. But to that get full mark, that's why the problem lies. You cannot get full mark. Why can't you get full mark? Because you only give us half of the solution. Why is X equals to 53? You must tell us. X equals to 53 because they are angles on the same segment. You don't have to write story. Get that one in mind. You can just write same segment. As simple as that.
Hello, Mr. Additional. The, the class will end in the next 2 minutes. Should we reconvene or you are going to end there?
At least let me give them only my phone battery is somehow low.
Okay.
At least 5 minutes. At least 5 minutes.
Okay. So I'll come on with it. I'll send the link on the group to join us. So once it expires, yeah, I'll send it.
Okay, no problem. Yeah. So please take note. When it comes to self-geometry, you must give reason. I don't to write story about the reason. X equals to 53, y, same segment. Y equals to 53 degrees, y, same segment. That's just it. You don't need to say angles in the same segment of a circle are equal. No! It is the math teacher that will mark your street, not a biology teacher. If the biology teacher, that will be looking for angles in the same segment, but math teacher, once you put same segment, he knows that you are trying to what? Angles in the same segment. And that's all about this theorem. Angles in the same segment of the circle are equal. Do you have questions?
No, sir.
Okay. The next theorem is angle in a semicircle. Its right angle. That means 90 degrees. Please remember what I said earlier. We have to learn like this. What do we call this? What do we call that line? Let me read it. Line PQ. What do we call line PQ? Sorry? We
Diameter.
I'm sorry, that's a line okay. I'm coming back.
Diameter.
All right. Let's wait for others to join. Okay. So let's wait for them to join.
Yes. I'm waiting
That
for
is
you.
two of them have joined. Ajani has joined and Olayemi too has joined. No problem. So after 1 minute, so we continue. You watch the replay
Okay.
because of time.
Okay. Okay.
Okay, we can start now.
Olayemi, unmute yourself, both of you, unmute yourself, because you have to answer my question.
Sir.
Are you there?
Yes, sir.
I said,
Yes,
this
sir.
slanting Q, what does it stand for?
Diameter.
Diameter.
Diameter. Yes. Because you agree that this one is a diameter, isn't it?
Yes, sir.
Yes, sir.
Because you are wrong.
Oh,
You are surprised. I told you,
sir.
whenever you are in, hello, just hold on. Whenever a line like this is drawn in a circle, and it is not stated somewhere that, okay, like Q is a diameter. Don't assume it's a diameter until when the center is indicated.
Okay. So that means it's just a chord.
Are you
It's
getting me now?
Where it gets diameter.
Please.
Yes, sir.
Yes, sir.
Don't assume it's a diameter. One exam, there are sometimes that the text will not be that perfect. If you get a line, it will look like, okay, can we all see this? If I draw a line like this now, I draw a line like this. Are you saying that the second one is passing through the center? No. So they must say that line that we have drawn is a diameter. Please take me. And the diameter is divided the circle into two. That's how we call it semicircle. The angle in a semicircle is a right angle. That is, this diameter, any angle is formed on the circumference must be 90 degrees. Nothing more. Any angle that this diameter forms on the circumference, if I form another one like this, you can see this must be 90 degrees. If I form another one, this must be 90 degrees. Please take note. Very, very important. Now, if that's the case, you see, we are getting into another aspect whereby they will combine circle geometry, are you see now, with trig ratio because it's angle 90 degrees. They will combine circle geometry with trig ratio. You can just say that maybe this angle is angle theta, this side is 6 centimeters. Okay, let me put 30 degrees here. What is the radius of the circle? I will have a point. This angle is 30 degrees, this is 6 centimeters. What is the radius? You will know that this is the radius that we want to find. You cannot just find that radius without finding the diameter. So what I expected to apply that situation is what? We just trig ratio. Don't worry, by Wednesday, God willing, we are going to round this circle directly up so that you can have full knowledge of the whole thing. And I'm going to send the question to Mr. Yaku. I will forward the question to you. Please, Prof, you have a question to ask?
No, sir.
Anybody? Question?